My name's Angela Wilks, and along with my colleague Mandy Oglesby, we received an NIH grant, a multi-PI grant to study the regulation of heme utilization with the small RNAs, in particular of Pseudomonas aeruginosa, and these are critical for virulence in host pathogen interactions. So the grant was just under $2.5 million. We have 5 years to study these mechanisms in Pseudomonas that are related to virulence. And it also involves two of our colleagues external to the university who we've both worked with for many years and who have expertise that will also contribute to what is really a translational research project.
My name is Mandy Oglesby, and my role in this project is understanding how some small RNAs that we've been working on in our lab for a really long time contribute to regulation of heme uptake by different bacterial pathogens, including Pseudomonas aeruginosa, which is a really important and notorious antimicrobial resistant bacterial pathogen.
So the goal of the project, as I see it, is to understand how Pseudomonas in chronic infections in biofilms in the host utilize heme as an ion source and how that relates to the regulation that pertains to other virulence factors that allows them to establish these chronic and often untreatable infections. This is a very interdisciplinary grant award in that, I have a biochemistry background that is more sort of focused on biochemical mechanisms. My colleague Mandy is a microbiologist, so we can bring the two expertise together to really, challenge this project. And the goal is, if we can understand these systems that are important for chronic infection and establishing and maintaining these chronic infections, that down the line we'll be able to understand how to target these as potential mechanisms to disrupt these biofilms and be able to treat them.
One that's very cool that we're developing in the lab right now and we're excited to integrate into this project is being able to grow and really look at under a microscope in detail a bacterial biofilm. And since biofilms are really common for chronic infection and they contribute to antimicrobial resistance, we want to use that system to study these processes.
Understanding these processes certainly will affect future research as well as how we think about targeting bacterial infections.